I wanted to talk to you about my new crate, Axum-Anyhow.
Axum-Anyhow. Fantastic name.
Oh, yeah?
I mean, it's alliterative. I feel like anytime you get an alliterative name, it's going to be a winner.
I think what I'll do is I'll just describe first what Axum-Anyhow is. I wanted to maybe go through what it does and then show you an example that I'm using as motivation. And that example starts without my package. And then I thought we can start by looking at how it works, what it does. Using my crate, we can iterate on that to the solution that ends up using the crate, which will end up being simpler.
Sounds good. Yeah, that sounds good to me.
So let's see. I think I'll just show you the quick start, and then I'll walk you through what it does. So Axum is a web server, and Anyhow is an error library that makes using errors in Rust a little bit more friendly. This is the solution, by the way. This is already using my crate. So this is what it would look like if you were using it. So if you're using Axum, what you would do is you would have a main section. And in the main section, you create a router, and then you say, okay, here is the endpoint that this app will provide. In this case here, we just have one endpoint, and it's handled by this function called getUserHandler. If we take a look at the getUserHandler, you can see what it will do. Well, first of all, we're going to get the user ID. It's going to be passed in as part of the path. So /users/1, for example. And then when it comes in, we're going to get it as a string. Now, because we know that it's a number, normally, if you're building an endpoint like this, you would actually accept an integer here. But for the purposes of demonstrating the library, we're accepting a string so that we can demonstrate a parse error. Axum has to return either a result that's going to go back to the user that is a 200 OK, or it's going to return some kind of error like a 400 or a 404 or something like that. So with our crate, let's say we try to parse the ID and it fails because let's say it's not an integer. In that case, with our crate, we can do this nifty little thing where we say context bad request, and then we pass it back a title and a detail, and then we put the question mark operator. And so what this will do, it will immediately return a 400 bad request if it can't parse into a number, and specifically like an unsigned integer, and then it will like short circuit return. Otherwise, if it succeeds, we'll have the ID. And so this ID will now be a number.
Two questions real quick. One, and I'm not sure if this is from Axum-Anyhow or if it's a fancy Rust thing that I'm not familiar with. You have path parentheses ID in the parameters.
Yes, that is an Axum feature, and it's basically saying find the ID in the path of the URL. I actually don't know how that works. I feel like I've been writing Rust code for over a year, and I still feel like a beginner. This is one of the few languages that make me feel that way.
It has so many fancy features.
Yeah.
I mean, I would guess it just pulls out the ID variable as you define it in the route.
Mm-hmm.
Like, I bet if you made it something other than ID, it would like crash on compilation. The second question I had was why prefix bad request with context?
When you're using Anyhow, the Anyhow error processing library, it's often the case that you want to add context to an error before you return it. And so Anyhow provides you with a .context method. So when I was developing my crate, I liked the context word to say like add this context to the error message. And so I extended the usage of that term. I think it's useful maybe for us to look at context in Anyhow. So this is kind of what they provide. They have a context and they have a with context. And the reason why I decided to use context is when I looked at other options, there's like a map error, for example, which kind of sounds like the right idea as well. Like, you know, if this error occurs, then map the error to a 400 bad request or something. I could make the interface be similar. The reason why I decided against it was that the map error takes a function as input, and I didn't want to change the expectations of the interface if I was going to overload the term. And so I chose context because if you look at Anyhow's context, they take a context C, which when I use it, it's a string. Okay, so we were saying, all right, so we have context bad request. Now, let's say that you don't pass a context. If an error occurs and you just stick a question mark on it, it will convert it into a 500 internal server error. Our crate will do that. Here's another example where if the result is not an error, but an option. So this db get user here returns an option. So if we get that, we can do .context not found. So this will produce a 404. So in other words, these contexts can be applied to either errors or options.
So you said that your crate also converts the database connect. It says it converts that to a 500 error. There's like some automatic hookup basically that Axum-Anyhow has.
Yeah, it might be useful to take a look at how that's done. Maybe right now. So here is my struct called API error. And this API error object, this is actually how Axum says you should do errors. Maybe after we go through this, we can look at what Axum suggests for doing error handling so that we can see how it would have been otherwise. So here is our API error, and I'm following like a standard. Like there's apparently a standard for when you return like JSON status errors that you will have like the status code. So not only does HTTP return like a 400 or something like that, but you will include that number inside of the status field inside of the JSON response. And then we have like a title, a detail, and an optional error that caused the original error. This is not serialized, so this part here doesn't go back to the user. It's just there for actually it's for logging purposes. So I lifted this out of Koso, then I rewired it back into Koso, and Koso had this error there. And we had a hook in Koso that when we return an error to the user, we would also log the error to the console, so that we could, see the kinds of errors that were happening. And especially like 500 internal errors, it was useful to see the details. So that could get logged by stashing the error here.
Very handy.
Yeah. So now here's the impl for API error. We have a builder that allows us to build it like this. If you have an API error, but there's no context and you didn't build one, this is what turns it into an internal server error.
Got it.
Then we have this one, impl from E for API error. This part here is what we need to parse, okay? So what it's saying is if you have something that can be turned into an anyhow error, right? So E is the generic whose constraint is that it can be turned into an anyhow error. Then we have this impl that allows you to turn those types of objects into an API error.
Makes sense.
Cool. So that's the first part. Then there is the part where we extend result and option, which was, I think, your original question. Now we're going to head over to extensions. So in extensions...
So yeah, just jumping in. So error basically just defines like all your basic sort of functionality that basically enables things to work at all. And then extensions is basically going to hook it into Axum itself. Is that how it's organized?
Extensions is what's going to enable us to extend result and option.
Yeah.
Okay. So here's our first one. This is the trait. Oh, sorry. This is a sealed trait. Let me find the unsealed one. Oh man.
I actually don't know what sealed traits are. What's a sealed trait?
I'll get back to that. That's
Private trait, basically.
It's a means to prevent people from implementing your trait. So I don't actually mind if somebody implements my trait. The problem is that we're using semantic versioning. And if I add a method to my trait, let's say a new context, some new status, like context, I'm a teapot. If you just add the method to the trait, it's technically a breaking API change because anyone who implements the trait will now have to implement that additional function in order to update the package. And so I sealed it so that the tool I'm using to do the automatic versioning for me does not detect it as a breaking API change and only increments the patch version, not the breaking API version change. Yeah. So that's the only reason why it's sealed. But here's the important bit. Here we're saying that we're implementing this thing called result ext for result. And it's saying that this result will take, is parameterized by T and E, where E is into an API error. The gist of it is that inside of our library, we are allowed to implement the trait. And that trait basically says that we have to implement context status, context bad request, so on and so forth. Okay.
This is interesting, though. I never really looked into like packaging up any of the Rust work I had done. So it's interesting to see that side of like, I assume semantic versioning is like pretty popular.
Yeah, well, it's also super important because you have a lot of automated tools nowadays that will auto update your packages for you. If you follow semantic versioning, those tools will not automatically update to breaking versions for you, and that's nice. But a lot of my changes are not breaking API changes, but the tools that are automatically updating the version number for me will say, well, actually, it is, right?
Would you say it's fair that in a sense you like under semantic versioning, which is like, okay, all the changes are like safe. You're basically like unsafe.
I don't know because I don't actually understand unsafe. Are you talking about like Rust's unsafe?
Yeah, like Rust unsafe. Like it's not. I know you're not literally using Rust unsafe, but it feels semantically similar. Where you're like, ah, yes, I will seal this trait, but then I'll have an unsealed trait that exposes the same functionality.
I see what you mean. It's like an abstraction that wraps the dangerous bit. You put a coding around it so that there's this one version of the trait that you actually expose externally, but is not extendable. And then there's a second trait that is the internal one that you do want to extend.
I have a side question. What is in your sealed trait that's not in your public trait?
So here is the trait, and I have an object called sealed result. And if we hop over to sealed result, here's a module called sealed. And by default, modules that have no visibility makes it private, right? So this sealed module is private as a result. And so what I do is I define 3 traits: sealed result, sealed option, and sealed into API error. And then this...
And it's just empty.
And it's just empty, meaning to say there's nothing to implement in this trait. Then result, and then we can look at where this is used. It's used here. Go to it. But it's basically saying you are one of these sealed result things. And I can define these things and then implement them myself somewhere else, which is, down here, basically. But other people can't. So all that stuff in the crate makes all of this possible. Before we dive into the writing of the code, my original plan, why don't we look at how Axum actually tells you should do errors? I think it's instructive because I'm essentially doing that. The benefit of using the crate is then you don't have to. The downside is that if you adopt the crate, it's less flexible than if you did it yourself, as is usually the case when you adopt anything. So let's go take a look at how Axum does errors. Here is how Axum suggests you do the error handling. Here's an app error. So what you should do if you're using Axum, what you're going to do is define your own internal app error. Then in the code that actually handles a request, you'll try to do stuff and you can put this question mark here. And the reason you can put this question mark here is because there is an impl to convert whatever error this is into an app error. Mm-hmm. Okay, that exists somewhere in this file. And so you have to write that. Okay, the important bit is that it preserves this niceness where when an error occurs in your code, you can just stick a question mark on it. And then down here, you actually tell it how to take your error and then return it to the user. Okay, so in this case here, if a time error occurred, then this will become a internal server error and then something went wrong. And now the problem with this, and the reason why we didn't adopt this pattern when we were building Koso, is that oftentimes what's happening here is too far away from here.
Yeah,
right?
your context is just spread out across maybe even like multiple files, right?
Yeah. If we put a question mark on something, it's a thing that shouldn't happen. We expect just those kinds of errors to turn into 500s. Because that's a standard pattern. So that is what's happening here, but that isn't what is happening for the JSON rejection. For the JSON rejection, it looks like we're taking some status code and pulling out the body text, and this is the error that we're using here.
But the pattern they would wind up with is they'd have to have like any custom messaging down there in the into response implementation.
Yes, correct. And this would probably live in some file called error.rs. Far away from where you generated the error, right?
And it would eventually grow very large.
Yes, exactly. Now, as it turns out, Axum does support anyhow as well. So there's an example for anyhow. So let's take a look at that one. This one here is a little better. And so like there's bits of this code directly like inside of Axum-Anyhow, right? Like this bit of code here is just in our library now. And you're starting to see sort of where the idea came from. Here's the gist of how this bit of code works. You create a struct called app_error that contains within it an anyhow error. And then there's these bits of logic to like convert app errors into a response for the client. That's what this bit of code is doing. And then there is a thing that converts anyhow errors into app errors, right? Meaning to say, if you have an anyhow error, you can get back an app error. And if you return an app error from some handler, that can be turned back into some response to the user. So this is pretty nice. And if you try a thing, this will work. The problem with this is you can only do 500 internal errors now, because like right now, everything only ever turns into internal server errors. Right?
Oh, yeah, that's not cool.
You want the best of both worlds. And the best of both worlds basically entails doing something slightly more sophisticated, and you can definitely do it from here. And the way you would do it is you create your app error, and instead of just wrapping like anyhow error, you wrap the status code you actually want to respond with, and then populate it with a value, and then when you return, you use it. And that's all Axum-Anyhow does. Like it's let's head back and we can see it in action. Now that we have all the context, if we look at it, it's just we got the status code, right? We got the title, we got the detail, and we provide methods to populate those fields. And then you still have the question mark, but now the object that's going back is this API error, and that API error can be turned into a response via the into_response function we have somewhere in here, hidden, buried in all the comments, right? So that's kind of the gist of it. Now, this is how Axum suggests you do the error handling. I made a demo for us to play with.
Nice.
So here's our demo, and I think now is a good time to see the migration, right? So here is what your code would look like in its simplest state. So if you didn't use the examples from Axum about how to do error handling, and you didn't use rcrate, then you have to return something that can be turned into an error response. So Axum requires that all functions be infallible. They must never fail. That doesn't mean that you can't return a result. It just means that the error part, both the OK part and the error part, both need to be able to turn into a response. As long as that's true, you can do this, right? Now, there is something that can happen automatically though, which is if you have a result object and the first part here is the OK and the second part here is the error part, if it's a status code and something serializable to a response, this is sufficient. Like if you do this, it will successfully return an error. So, like looking through our code, we have this bit of code that says, okay, try to parse the ID. If you succeed at parsing the ID, then ID. Otherwise, we failed. And so we're going to, return a bad request. And so you return error, status code bad request, and then what you want to serialize out to the output, right? So this JSON error response. And here's where we've defined our error response.
So this is without anyhow, this is just like you're doing all the Axum error handling yourself.
Yes, that is true. Yes. We are using anyhow. Let me show you. That was actually a thing that we maybe skipped over when we were looking at the original example. So here is our mock database. Okay. So our mock database contains a users table, which is a hash map from integer to some static string. And then here's the implementation for it. We have a connect, and connect is actually infallible in this case, but I wanted to make it fallible.
Yeah.
So it's a result of self and then returns OK. And then here we have this static definition of the users table. So user 1 is Alice, user 2 is Bob, user 3 is Eve. And then we have a get user. And what get user does is you pass it an ID. And if the ID exists, if the value is in the map, we return a user object. A user object looks like this. So it has an ID and a name. And if not, then we return none. And then down here, we have one other function called parse ID. Now, this result object here is anyhow, right? And this result object here, also anyhow.
Oh, okay.
Yeah. So what anyhow does, well, it does a lot. And unfortunately, I'm not smart enough yet at Rust to properly explain it. But errors can be different shapes and sizes, which means that the amount of memory that they take up is variable. And so as a result, these things need to be put in a box dine. Sorry, internets, if I'm all wrong, but that's something like that.
Oh yeah, I'm quite familiar with the box dines. You got to throw it in a box dine so you can have a dynamically sized box.
The point is that lots of things can be turned into anyhow error. The benefit of them having done all that work is that we can then do this little trick where into anyhow error leverages all of their conversion logic, right? Anything that can be turned into an anyhow error can also now be turned into an Axum-Anyhow API error. I think that a lot of people who are now writing Rust code, they probably adopt anyhow. Even if, let's say, a library author doesn't use anyhow, our library can still work with it as long as it can be turned into an anyhow error.
Which most errors can.
We converted all of Koso over to Axum-Anyhow, and we didn't encounter that problem. Anyway, let's convert this into Axum-Anyhow.
We're going to get to delete so much code, is what I'm assuming?
Yes, we will. And that's going to be the fun part. But this isn't like the Axum examples of error handling. The reason why this is here like this is because oftentimes you do want side by side with the operation you're doing, you want that to be side by side with the error you're returning when an error occurs. And from that perspective, this code is nice. It's like, that if a parse error occurs, you want that to be turned into a bad request, right? The database doesn't know that, right? In a parse error, that's just going to return some error. But at this point here, we are in the handler. And so anything that we have called that can return an error, at this moment, we know what it should be. And at this moment is where I feel like when I was developing Koso, when we're in the handler, that's when I want to say, that's a bad request. Please send back a bad request to the front end. And my trouble that I had with the Axum error handling documentation was that they pushed it down, right? They necessarily have to live in a different file. The purpose of defining it this way is that, okay, if a JSON rejection occurred, return such and such status code. If a time error occurred, return some other status code. All of this lives in the error.rs file. And so what that means is that in your business logic, wherever the handler is, you need to know, okay, I'm going to return a time error, and that will be a 500 error because error.rs said so. With this bit of code, a parse error is a bad request. And when we were writing the Koso bits of logic, we liked this. But this becomes very verbose. I mean, you can just see it's verbose. Okay, let's convert. So this result is a standard anyhow result, I believe. Yep, anyhow result. Let's open up a terminal and let's add cargo add. Let's add Axum-Anyhow. Cargo add Axum-Anyhow. Okay, and then here we will say API result, and then we can just remove this bit. And we actually no longer need an error response object because that's basically what Axum-Anyhow provides. It provides the error struct for you. And that is actually its biggest weakness. If you need something that is more than status title and detail, currently it can't be used for anything else. We can talk more about that, ways to extend it later. But until I actually have some users, I'm not sure it matters.
Yeah. No, it seems like just the bare bones for like what you usually want when you're just spinning up a web server.
Mm-hmm. So let ID equal parse ID, and then we'll pass it ampersand. And then what we just do is say context, and we have access to all of the different contexts. I love VS Code that it's able to do this because I haven't even imported the result ext yet. Sorry, I may be getting ahead of myself. Let me show you what that means. So we're going to hit this bad request. And then for the title, we just need to pass this and pass this. One more thing, question mark, semicolon. And that's it for this one.
13 lines to 2.
13 lines to 2.
And no loss of clarity.
It does make things pretty nice. For this bit here, because we just want this to be an internal server error, this one here is actually pretty nicely handled, I would say, by the out of the box Axum stuff, because you can build your own API error whose default implementation is to return internal server error. So you do get this one out of the box, but you still need to make your own error struct, and you do need to write the into response for that error struct so that it can be converted into a response to the user.
Just to clarify, so Axum by default, any error occurs, it's gonna 500.
No. For Axum by itself, all responses must be infallible. You're allowed to have a result object that can be turned either the OK or the error can be turned into a response. Whatever the error is has to be turnable into a response. Anyhow, errors by default aren't. They can't be.
So I think I was like slapping with the word default. Axum pushes you very heavily to go define your own error. What do you do if you just don't define your own error and you're not using any other error handling? Does it just panic?
Yeah. It won't compile.
So you're kind of forced to do the laborious process that you laid out, where you have to go to the 3 different places. You have to define your own struct with its own fields you're into. So you basically can't have an Axum server unless you panic.
Well, you could also do what we had before here, where for every possible error that you get, you match on it. And then in the case of an error, you return status code and the response body. You can also do that. And actually, when we were building Koso, a lot of our code ended up looking like this. We would have code that was not specifically handler specific somewhere else in libraries, and then we would call into them, and those would always return anyhow results. The benefit is that all throughout our binary, we're using the question mark operator to propagate errors, and then the handler is the only place where you catch those errors and then finally convert them into the response for the user. And that part, there's no way around, right? Our library requires you do that. Axum requires you do that. The difference is primarily in just how nice it is, right? Like this version of the nice versus this version of the... I wouldn't say this is terrible. This is not the worst. It's very explicit.
It's fine.
Yeah. I don't hate it. I was fine with this back in the day, but then when Kyle started the implementation of this, and when he did that, I was like, this is just so nice. I love this. We need to expose the world to it. Please have this world. It makes life good. And even if you don't use Axum-Anyhow, like it's not that much work to make your own struct that extends the result ext or the option ext that allows you to then do .context and convert it into a BAT request.
But for the 500 cases,
yes.
So if you just have any error that
yes.
occurs,
yes,
your code won't compile, basically.
Correct.
Okay. So what do you get out of the box with the question mark that you were saying before then without Axum-Anyhow?
You don't. You have to add an implementation to allow you to use the question mark.
Oh, so were you saying that Axum-Anyhow gives you the nice part out of the box?
Their example does, yeah. Sorry. What I meant was, let's go back to here. If you look at this file, you can see that they've enabled the question mark operator here, right? What I was saying was that this question mark, so in order for this to work, they had to implement they had to implement the struct here, they had to implement this thing here, and they had to implement this bit down here. All of these things were necessary for that question mark operator to work, right? It's not much, as you can see. It's like, not a whole lot, which is why I would say it's not very heavy to ask the user of Axum to put this in their code.
This is what you're saying you get out of the box, like with that little lift, you get the nice question mark conversion into 500s.
Correct.
Not quite by default. Yeah, you got to put the batteries in.
You mean like if you're using this, right?
Yeah.
Yeah,
with Axum-Anyhow, you get batteries included, right?
There's some batteries included, yes. There is a trade-off, and that trade-off is here you can implement the struct however you like.
Yeah.
So if you want the response to be different to the user, you can make it different. Adopting Axum-Anyhow forces you into using our specific format for the API result. And that's why I used this RFC, and I'm sorry internet's for white screen all of a sudden. On the bright side, no pun intended, my face is now well lit. Yeah, so this one here, like this RFC defines status, title, detail, as well as a few other things that don't really make a lot of sense in our use case. There's also a JSON API. I don't know how many people know. Do you know about JSON API, Ethan?
I don't think so.
So it's kind of like, how Google has they released their AICs? AICs? Is that what they call them?
AIPs?
AIPs? That's right, yes. It's similar to that. I think this precedes a lot of Google's ideas, but basically this was a thing that I had adopted a long time ago when back in my Yahoo days. The gist of this is when REST was starting to become popular, a lot of people would argue about what fields should be included inside of your REST API. And so this was written by some folks who thought it would be useful to take a stance. Any approach is probably fine, but taking a stance is nice because if you're all standardized, then you don't argue anymore. Kind of like code formatters. If we look at the error objects in JSON API, they also have a status, a title, and a detail. So I liked that this document overlapped with the RFC 9457. They're using similar fields. And so I adopted the stuff that was in common between the two. And interestingly enough, those were the same set of fields we had defined for COSO without looking at these docs, because that's all you need: status, title, and detail. Now, at some point, I thought maybe I could implement this meta. This would allow an extensible endpoint, but again, until a user actually asks for it, it's fine. Like, we didn't need it in COSO, so until a user actually wants it. But this would be a good way to extend the object so that you can include your own fields, whatever you like. It would just basically be an option of value, where value is from the SERDI JSON.
Yeah, just arbitrary JSON blob.
Yeah, let's finish this and then run it for fun. So we'll just user, and then here we say, this is going to be a context not found. So .context not found, there it is. And we'll just grab the title and the detail, and then you just put a question mark at the end here. So in this case here, this was an option, and then this context converts it into an API result. So if this wasn't here, you could just do .context, and then there is a context from anyhow that can convert an option into a result. And this is also why I adopted the context _ other things to convert to an API result. It's following anyhow's usage of the word.
I think that's a good idea. I just want to call it because I think context not found is doing something else nice. So get user returns an option. Context not found returns a result wrapping user, right? So it also,
Correct.
under the hood, resultifies everything, which I think is quite nice. I remember when I was learning Rust, there was just like, oh, is this one an option or is this one a result? Is this one an option or this one a result? I was doing a lot of like JSON parse error stuff, and it was just very annoying.
Yeah. Were you using anyhow back then when you were doing Rust?
I wasn't. No, this was, I don't know how long Anyhow has been a big thing, but this was like 3 years ago. I actually don't know, like the speed of light in the Rust community.
I don't actually know. I know that it feels like when I adopted Rust, things had slowed down a bit. It wasn't quite so fast moving, which is sort of where I like it to be. I'm happy with things being not too slow, like not go slow. Rust slow is a good speed.
Yeah, it was around. Anyhow, it started in 2019.
I forgot what the name of this thing was, but there's like a place. There's a place on the internet where there are some like Rust libraries that are so good in terms of popularity. They're almost as popular as the standard library. And so like the Rust community have sort of given their vote to these packages. I forget what it was called. Oh, well, if we don't find it right now, I will post a link somewhere. Blessed RS.
Oh yeah, SERDI. I don't know how to say it. SERDI?
SERDI? I don't know. Serial D. SERDI? Sir. I don't know. I've always pronounced it SERDI, but...
It rolls off the tongue better. I'm going to steal your pronunciation.
Thanks. We stumbled on this some time ago. It was useful to come here because, Kyle and I often wondered which library should we adopt for something. It's nice to know what is the most popular, what are people using.
Yeah, I think that like comes down to like being the most important factor. Like, will this library be supported in the future is kind of the most important thing.
Yeah, because when we were first starting out, we were looking at Rocket because I liked Rocket's routing. They had like an instruction for routing, and we were sort of flip-flopping on what we should do. We didn't know about this webpage. If we had, I think, let's see what they say. Graphics, concurrency, CLIs, databases. Well, HTTP. Okay, HTTP server. Here we go. Axum and Actix Web. See also, and Rocket's there. But anyway, we adopted Axum.
This is a not so opinionated list of HTTP servers. It's like, there's 2. And if you don't like those, here's 4 more.
Fair enough. Okay. So in order to be able to use the question marks here, we need the ability to convert result into API result. And so from Axum-Anyhow, you need to import option ext and result ext. These traits make it so that that can happen. Oh, and that's interesting. I didn't know. Oh, when you click it, it shows you where it comes from. Yeah, that's neat. Click it up here, and then it highlights it down there. Click it up here, and it highlights it down here. Okay, got it. Let's run some code. Man, we're like an hour and a half in. Cargo run. All right, it's running. I have this demo HTTP up here. I'm gonna put it down here, and then this basically allows me to send requests. Click.
Is that an extension you have?
Yes, it's called. I have too many things. REST client. It's called REST client. It's got a lot of good ratings, lots of downloads. Nowadays, people use HTTP YAK.
Same thing.
It's very similar, but it doesn't produce the same output for me. And so, I don't know, I get stuck in my ways. I should move to the one that's supported. But this is fine. Okay, so we sent user 1, it pulled back Alice. So now, if we send user 0, that's going to return none from the database, because if we look at the database, there's no 0. So this will return a 404, not found. Send that. So we get 404, not found. And you can see the HTTP status code there too. Now we'll send A. So A doesn't parse to an integer. And so this is going to fail here with a parse failure. And then it should fail on this line with the invalid user must be a number. Send request. Yeah, there we go.
Nice.
Yeah, nice.
Very slick. I just love this way of like formatting errors. It's just so simple.
Thanks, Ethan.
Most people won't be familiar with this, but previous frameworks that we've both used in the past at previous places, in Java, they have just a set of exceptions to find, and you just throw those exceptions, and it's like, not found, internal error, bad request.
Mm-hmm.
And it's the same thing.
Yes.
It's just so convenient.
Yeah. I feel like Rust's question mark operator is really, really nice. So like while I like Go for a lot of things, I find when I write Go, always check the result if the error is not nil, and then do something that always felt a little bit tedious. When I think about Go, it's nice and simple in many ways and kind of obtuse in a few others. Yeah. Well, anyway, thanks for hanging out with me, Ethan.
Yeah. T-Chat, it was fun.
Yeah. Bye-bye.
Bye.